main question I always get when I tell people what I do for a living is, what is material science and engineering? When I was figuring out what I wanted to study in college, I learned this research area wasn't as well known as mechanical or aerospace engineering. But material science and engineering permeates these disciplines, which is what made it special to me. Anything you can think of, metals, ceramics, plastics, even our own skin is a material. And my job is to synthesize, develop, and find new ways to improve current materials for future applications. As Dr. Shine mentioned earlier, NASA's Glenn Research Center has a rich history of materials advancement, having a core competency of developing new materials, protection systems, and structures for extreme environments. That means extreme temperatures, pressures, or very corrosive environments. As you can imagine, with our current goals of returning humans to the moon and eventually onto Mars, advanced materials will be equally important in protecting the lives of our astronauts, Earth-based flight vehicles, and human life here on Earth. Unlike most who are inspired by what we do at NASA, it wasn't dreams of space or being an astronaut that steered me here. It was NASA's first A, aeronautics, that got me excited about pursuing this career. I started college as a studio art major with no desire to go into any engineering field. But I knew I loved flying, I loved traveling, and I loved how flight made my world bigger and the rest of the world smaller. So when I changed my major to physics at Auburn University, I was left bewildered, not knowing exactly what future career I'd want. Then I came to NASA Glenn as an undergraduate intern, and I was able to work on aerogels, which are very unique, lightweight, highly insulative materials for thermal protection systems for vehicles like the Space Shuttle and other high-speed flight vehicles on Earth and in space. And at that time, it was like I had found the missing piece of the puzzle of figuring out what I wanted to achieve with my life. I wanted to work on advanced materials to protect human flight systems. And Cleveland was where I needed to be to accomplish that goal. Once I started graduate school in Pennsylvania, I was awarded a graduate fellowship through NASA Glenn, and I became an employee as a Pathways intern right before I defended my thesis. That aerogel research that set this once inexperienced intern on the path to NASA was just one example of the vast amount of influential work accomplished at Glenn Research Center. And today, my team and I are continuing that tradition of innovative materials research in a number of ways. Some of our current research involves environmental barrier coatings, which are used to protect gas turbine engine components from their corrosive environment. It's important to protect these components as our nation's next generation airplane engines will run at higher temperatures to improve fuel efficiency and reduce harmful emission products. Decades ago, the first generation of these coatings were developed right here at NASA Glenn in Cleveland. And now, my team and I are pushing state-of-the-art technology in current engines today. I'm excited to help develop coatings and lighter weight materials to help replace heavier metallic engine components. During engine operation, we investigate how these coatings and components fail, whether it's by corrosion caused by combustion products like water vapor, or by particle deposits caused by ingestion of desert sand or volcanic ash. We collaborate with commercial engine companies to qualify their materials for flight readiness in our testing rigs that can reach temperatures above 3,000 degrees Fahrenheit. But we also never forget the fundamentals of basic materials characterization and new materials discovery. On the space side, the S in NASA, we are investigating lunar dust mitigation strategies for structures on the moon and eventually onto Mars. The Apollo missions taught us that one of the greatest challenges is how to remove very fine, highly charged dust particles from surface materials like solar panels, spacesuits, and helmet visors. Dust compromises the functional integrity of these materials, and so we must develop better removal technologies such as anti-adhesion coatings, brushes, or electric discharge techniques if we are to effectively live and work on other planetary bodies in our future. I've highlighted just a few of the many technical achievements and challenges we face in our pursuit of pushing the limits of what we can accomplish. And NASA Glenn will continue to solve tomorrow's problems today. I am thrilled to be part of the Artemis generation, contributing to that rich tradition of innovation. Working here has been a singular experience for me, and I personally take pride in saying, NASA is with you when you fly. Thank you.